Hello everyone, we've already been through the process of building Linux distribution absolutely from scratch within this series. What we did so far was like compiling Linux kernel and compiling BusyBox. We've been using the statically link one, and then we've been setting up networking and even Wi-Fi, and everything worked like a champ, but there was a big issue. So the issue regards to the DNS resolver. So by default, if you want the standard applications like widget or CURL to work out of the box, what you want to have is the libNSS DNS, which is the part of the GLIBC, which I've been mentioning earlier. And since we didn't have GLIBC at all in the distribution, we couldn't really do those outgoing HTTP requests that easily. Although I've provided a hack, a workaround to bypass that sort of a thing when I've created the custom resolver in Go programming language. But still, that's not an option if, say, you want to set up some package manager or whatever system that requires downloading from internet, and usually those kind of things do rely on either widget or CURL. So this might be Git, this might be like package manager under the Golang, etc. So if you don't have the standard way of doing HTTP GET requests and POST requests if needed via the standard way with the standard utilities, you're not really going that far. So in order to resolve that, we are taking one step further in this video. So this video, I will build a bare minimum Linux distribution from scratch, but this time it would contain glibc. Okay, let's start with downloading and compiling Linux kernel now. So I just go to my desktop folder and I want to create a directory called Linux. Going into that directory, and I'm saying widget and https cdn.kernel/pub/linux/kernel, and I'm using the version family 5.x, and the particular version is Linux 5.10.76.tar.xz. All right. So let's have it now. So being downloaded. I'm not going to go into the detailed explanations on how to configure Linux kernel. Instead, I will just use the predefined configuration. If you're interested in the details, like which settings do you need to set up, which you don't need, I have an extensive video explaining that. So feel free to check that out in the playlist you're currently watching. Okay, and I just go to, okay, there is no folder yet, so we need to extract files first. So tar -xvf and whatever is there. Lots of files in Linux kernels these days, yeah. All right, so now I want to go into the folder, and here I say make x86_64 dev config. All right, so this creates required stuff here, and by the end it creates the file called config, just config like this, and I will now alter this file with the already existing one. So just want to say cp and home, my username, desktop monkey c monkey to linux config, and it's called kernel.cfg. I want to replace the config. Now to check this out, there should be for instance squashfs being available. Yeah, it is. And also my RTW88 Wi-Fi drivers, RTW88. Yeah, so just to make sure that this is the exact configuration I'm looking for. So again, if you're interested in details, have a look at the video. Compiling Linux kernel probably refers under this playlist. So I just can quick from here. I will now run make, but I will pause the video recording because this would be running for about 20 minutes on my system. If you're interested in watching the entire process, see the video, you can endlessly watch the flame burns, the water flows, and the Linux kernel compiles here in a playlist. Okay, we are done with kernel, so we have the newly created arc folder, and if we just go there to arc and then x86, x86, yes, and yes, probably x86 64, and here boot folder, yeah, cd into the boot. Here, okay, bza image is the file that we actually need. But for now, we just don't really need this. So let's clear the screen and go back to the working directory here, Linux. Okay, so next step is to download, configure, and compile glibc. I'm using the GNU glibc. There are alternatives, but yeah, I just like GNU glibc. So let's do wget and https and ftp.gnu.org and /gnu/libc, and the version I'm using is glibc 2.38.tar.gz. Okay, great. So here we have the glibc archive. So let's do tar-xvf glibc to extract everything here. Then let's go to the folder. Here I want to create two directories. So the first one would be called build, and to build glibc you need to have the separate folder. Another directory I want to make would be called glibc uppercase, and this is where we're supposed to be installing the compiled version of glibc. Alright, so for now I go to build, and under the build I say configure, and I want to set the prefix equals to nothing. So this means that glibc is going to live in root/lib. All right, so now we're ready to make, and again I will just pause the video recording, and once the compilation is done we'll get back. Okay, so the glibc has just done compiling, and the next thing to do is quite an interesting one. So we cannot compile BusyBox just right straight away from here, because there would be two essential configurations for the dynamically linked BusyBox we're supposed to be adding to the BusyBox configuration file. So the one is the config SYSROOT, and another is config extra CFLAGS. Extra CFLAGS would be containing the path to where the .so files, which are the shared object library files, are actually located within the root file system. And config SYSROOT is needed to use the headers and also those libraries, dynamically shared libraries, in order to actually compile the BusyBox itself. So there should be one intermediate step, which is to create the SYSROOT. So let's have a look what we have here. There should be less, and let's probably just go once upper level here. And so here we should have the glibc. Okay, yes, we have. So cd glibc list. All right, it's a little bit strange. Okay, yeah, sure, it's empty because we didn't yet install the glibc itself. So yeah, one more step I almost forgot. So let's go back to the build folder, and here I want to say make install, and this directory equals to going one level up and glibc. All right, so now we are installing what we've compiled to the glibc. Okay, now we are done. So let's have a look one more time. So cd to this glibc. Yeah, now we have all the files needed. Like for instance, if we list the lib, okay, what? Last lib. Yeah, here are all the shared object files we need for our system and for the BusyBox in particular, for the system in general and for the BusyBox in particular. Okay, going one level up. And here you see another glibc has appeared, so let's go to this one. Here we have the headers under the include folder, which also might be useful. And also under the lib, we have the statically, okay, cd glibc ls lib. Here we have the non-shared versions of the glibc, which is also helpful from time to time. Okay, well, at the very least, if you have the statically linked binary executable, but it still relies on the libraries. In that case, not .so files, but .a files are used on Linux. All right. Anyway, now it's time to create the sysroot. So I want to say mk create into directory called sysroot, right? And now a whole bunch of things to be done. Yeah, but before that, I probably want to create the user folder here because it's not available by default, and we are going to be symlinking the headers and the libs to the user folder a little bit later. So mkdir in the user. Okay, we got the user folder. Yeah, great. So now first we want to copy -r to copy recursively from the glibc directory and the glibc where we have installed all the files. So we want to take everything and copy this to the sysroot. Right now, if we list the sysroot again, we have the folders. We have the files and the folders being copied there. Great. So for instance, ls sysroot and lib now contains all we need. Great. The next thing to do, want to say cp -r. Now this up-level glibc, and first we'll use include, and everything from there will go to sysroot and include like this. And also I want to say cp -r from the glibc lib, and everything goes to sysroot and lib like this. Okay, so now it has more. So just to quickly check this out, so let's say ls sysroot and lib and grep, and I'm looking for .a files. Yeah, we have some there, libc.a for instance. Yeah, that's exactly what we'll be looking for. Great. But this is not yet enough because there are some more headers still required by the BusyBox compilation. Well, I'm cheating here a little bit, and I will be using those headers already available under my system. But yeah, if you don't have those, you just try luck by searching for those somewhere and just bringing them in. As the basis, people usually use the include folder from the kernel. So just give an address of just list whatever Linux and include. So this sort of guys are usually being used. So there are lots of headers under these folders. Yeah, but again, this doesn't quite work for me because there are still some headers missing. So the way I'm going is the following. So I just say rsync. So only copy those files that do not exist, and those that do exist, I just keep those. So -all to deal with directories, and I'm saying user and include, so whatever is available under my root user include on my system, and this goes to the sysroot like this. Okay, it takes time, but once we are done, the very last but not least thing to do, we need to create the user include and the user lib folders, because those are also used by the BusyBox when it gets compiled. So I'm going to be using Symlinking here. So I say ln -s. I want to link to include, and this is for the SYSROOT user include. Okay, and another one for lib, and like this. And now if we go to SYSROOT, you remember that user folder we've created, so just go to the user and list here. So here we have the symlinked include and lib. So let's say ls lib, and all the libraries are here. Okay, great. So going back to the working directory, which is Linux. And now if I did everything properly, we should already be capable of downloading, configuring, and compiling BusyBox. So I can simply say wget and https busybox.net/downloads/busybox-1.36 1.tar.bz2. Okay. All right, so now tar -xv J, because we're dealing with BZ2, and F, and the BusyBox archive here. And now we go into the BusyBox, and here I want to say make dev config. All right. Okay, and now the interesting part. So I say VICI, which is a text editor, and entering the config. And here I'm interested into our essential configurations. So the one is the SYSROOT. So let's find one. And another is extra CFLAGS, right? So SYSROOT, I want to say, so it's the relative path. So we are now at the BusyBox folder. So go in one level up. And then I want to use the SYSROOT. And for extra flags, I want to say SYSROOT /lib. And this should already be fairly enough to actually compile BusyBox. So I just write, quit, hold my breath, and make it. And BusyBox was successfully compiled. Great. So next step is to actually install it. So I say make and config prefix like this, and it's equal to the current working directory. And I want to create a folder called BusyBox uppercase and say install. Yeah, I just forgot to specify the -L under the configuration, hence it couldn't really find the libraries. Yeah. Okay, great. So now we should have the BusyBox folder here, and we do. So let's BusyBox. Now here in the working directory, I want to create the root directory. So this is where our root file system is going to live. Right, so we got one here, and now I want to say copy recursively, and all from the SYSROOT goes to the root like this. Okay, now we go into the root. So see what we got here. Great. Yeah, I also forgot to add the BusyBox actually. So I'm using the rsync here again for this purpose. So rsync and all and the BusyBox /BusyBox. I want to copy to root. Okay, now go back to root, last bin. Yeah, we have the BusyBox folders, and also there should be LZD, which proves that has been LZD. Yeah, we have that. Yeah, by the way, before I forgot, so let's go to bin and just open the LZD. So here it's using bash, but we don't have bash on our system that we're building, so let's change this to shell. It's not essential for system to work, but it is essential for LZD to tell like what are the particular dynamic dependencies on a single of the single binary executable. And by the way, I didn't know that LZD used the shell script. I thought that's the utility, but yeah, it's cool that it's actually a shell script. Okay, then here is the file linuxrc, which we don't need because we're not using initrd, but initramfs instead. Great. Now we need to create a few more directories, the dev, the proc, and the sys. And the next steps are I would just be copying some initialization files, and I would just be quickly talking through what those files are actually doing. All right, so I want to copy from home, cmk, desktop, monkey c, monkey do Linux, and init, ini folder script called init. We are now in the root, right? I want to copy it here. Now we got the init. So just very quickly to show you this init, yeah, some basic stuff, initializing networking, mounting file systems, system file systems, and then doing networking lookup, and then just executing asbin init, which is the initialization system for our distribution. Okay, then I want to copy the inittab to and inittab. So that's the initialization file for the asbin init from BusyBox. Okay, then let's also copy the logo. Not essential, but I really like that monkey see, monkey do logo. So here the logo txt. All right. Then we have the script for networking. It's called network shell, and it's going to here network shell. Okay. Then the shell itself. So this is the command if you want to run some, if you want to define environmental variables before running the shell, this script might be helpful. So again, all this has been covered earlier within the tutorial series, so feel free to see the entire playlist. Okay, and last but not least, which is quite essential for networking, is a file called resolv.conf, and this one, resolv.conf, contains DNS servers. So let's go to that, see what we got here. So quickly show you the logo. It's just a cool picture. Then network shell puts the router up. Okay. Then inittab, just the basic configuration. Shell has pretty much nothing here, just running the shell, but again, you can add the environmental variables before running the shell. And resolv, this one is interesting, resolv.conf. So here we use the DNS servers. Like the first one is Google DNS server, the second one I know where that comes from. But anyway, so these are quite essential. But this is not yet the end. There is another thing that we'll need to do, which is absolutely essential because otherwise this is simply not going to work. So we are now at the root. So, okay, no, hold on a sec. Where did it go? No. Desktop, Linux, root. Okay, here. So we have the lib folder, but we don't yet have the lib64, which is essential for the ld.so linking program. So I say ln, creating the symlink, and lib64. And now we have lib, and lib64 is just the symlink to the lib. Okay, now we can finally pack our file system, but before that I want to do a few more things. So let's also create the the ISO folder, and I just say minus p. So I want to create the ISO boot and grub. We'll also need to have the grub configuration. Less, okay. ISO. So now I want to copy the grub configuration. So home, CMK, desktop, monkey C, monkey 2, Linux configuration. Grub CFG goes to ISO boot grub, and this is called grub.cfg. Okay. Also, we need to copy the kernel. So I say cp Linux arc x86 x86 then boot, and then there should be the bz image. Okay, this one goes to ISO boot and bz image like this. Okay, and I want to check, so go into ISO with the name cd boot bz image with the name, okay, is, yes, it is exactly bz image. So I just need to make sure that the kernel is bz image, boot bz image. Great. Okay, so yeah, probably last thing is to pack our root file system and copy it to the ISO. So let's go to root. Yes, so here I say the following. I want to find all and pipe this to the cpio -o -h new c. So creating the cpio archive from these files, and then pipe this to the gzip, and then output to, so we are now at the root, going one level up. Then there should be the ISO boot, and we'll call the file root.cpio.gz as specified in the grub configuration. Yeah, it takes time. It would now print how many blocks has been used. Okay, great. And finally, I want to create the ISO. But before that, let me quickly check whether under the ISO, so ls ISO boot, yeah, I have the root.cpio.gz, which is fantastic. Okay, no, going back to Linux here. Okay, so now I'm using grub mk rescue to create the ISO image, and I want the output file with the name, let's call it monkey C, monkey do, Linux, let's say core glibc. Okay. And .iso, and I'm using the ISO folder as the source for this. Okay, so now we have the ISO. Now hold my breath and try to run it in QEMU. So I say QEMU system and x86-64. I want to say no graphics since I'm running this in a terminal. I want to use cursors for rendering instead. The CD-ROM image is, yes, CD-ROM is monkey see, monkey do stuff here. Okay, I want to say enable KVM for the faster virtualization, and I want to say the memory equal to 1 gig. And I hold my breath and try to run things. Okay, at very least bootloader is working, which is good. Yeah. Okay, back in RAMFS. Yeah, it's starting looking for networking and even gets the IP address. Great. And this means that all the commands that the applets of BusyBox essentially are working properly, which means that the BusyBox has been linked, which is really good. And now let's try to say wget https and example.com. And yes, we do connect, and we did download the file called index.html. So let's have a look. And index.html. And yeah, we got networking up and running, and we can do outgoing HTTP requests. So now the libnss_DNS is in its place. It's working properly, and we can use widget, which is fantastic. And this gives us a whole lot of opportunities for this repository, for this distribution to improve, like, for instance, adding the package manager, which is probably going to be the topic of the following videos. But for now, I just want to quickly show you so go into the lib, and this NSS, just go like grep NSS. So you see like libnss DNS and all this stuff. So these libraries are absolutely essential to make things work for the DNS resolution in particular. And again, one more thing is the ads folder. We have the resolv.conf having the DNS server addresses. And without this configuration file, this is not going to work. Pin would work because networking is being set up, but widget is not going to work. Okay, guys, this is it from my side. Hope you enjoyed the tutorial. And again, the next steps would be probably to add the package managers. So if you're interested, I'll see you in the next video. This is it from my side. Thanks for watching and cheers.